These notes will hopefully help you understand slope a little bit better. We will start with a definition. In its most basic form, slope is just the steepness of a line. So it can be something that's really gradual or something that's really steep. We will be using a number to represent how steep the line is. And the number that we're going to be using will typically be written as a fraction. Slope is a ratio that compares your vertical distance to your horizontal distance if you're looking at a line on a graph. The formula that we can use for slope can be written a few different ways. The first way is if we're comparing the horizontal and the vertical distance in a fraction. We will put the vertical change in the numerator and the horizontal change in the denominator. So slope is a number where you write the vertical change on top, horizontal change on bottom. A more simplistic way to think about that would be if we call it the rise over the run. So usually you'll hear slope as rise over run, and it just means how far up divided by how far over. It would maybe help to put some little arrows. So rise is your up and down distance. That's going to be your y value. And the run would be your horizontal distance. That would be your x value. Now, when we're looking at slope, there are 4 different types of slope. The first type of slope can be represented with just any line that's increasing like this. And then we'll have arrows on the ends to show that it continues on in all different directions. And that's going to be an example of a positive slope. Okay, if I use my little car here and put it on the line, I did put an arrow on the car to show that that's going up, and so that's an example of a positive slope. Next type of slope is basically just the opposite. That's when you have something that is going down. And again, we can put arrows on the ends. This one is going to be a negative slope. And so again, if I take my car with the arrow, I'm always looking across from left to right. If I put my car on my slope like this one, he's going to be going down. And so that matches up with negative. You can see that for a car, that would be a pretty steep slope if that's how steep his road actually was. Okay, a third type of slope is when you have a line that just goes straight across. It's not going up or down. If I were to put my car on a road like that and not push on the gas or push on the brakes or anything, that car isn't going to move at all. So that would be an example of zero slope. Okay, so a straight, horizontal, flat line is zero slope because that car isn't going to move at all. And then you might be able to guess what the last slope looks like. That is if you have a straight up and down line just like this. And if we put our car on a slope like that, that's going to be a problem because if our car is on a road like that, it's just going to fall off, and that's not going to be good if you're riding in that car. So that last type of a slope is called an undefined slope. Okay, and mathematically, if we're looking at a zero slope or an undefined slope, we could still write these as fractions. So remember that slope is rise over run. So for my zero slope graph, if I do a rise of 0 divided by a run of any number I want, maybe it's 5, maybe it's 10, anything like that, no matter what number I pick, that will always simplify down to 0. So that shows our zero slope. If I do the same thing for my undefined slope, this time I'm going up or down a certain distance, maybe 10 for this one, but I'm going left and right 0. And since you're not allowed to divide by 0 and actually get a number, that would be undefined. So just a little bit of math to go along with that. All right, let's look at a few examples. So if we're going to calculate an exact slope of a line, we need to find 2 points where it crosses the grid behind it. So as an example, right here, it crosses the y-axis and it crosses the grid lines behind it. If you look at those ones right there, it crosses on all 3. So that could be one point that I use. And then another point, this one right here, matches up on those lines behind it as well. So I'll go ahead and use that as a second point. Now what we're going to do is draw in a slope triangle. So I'm going to do my vertical distance first. So from this point right here, I'm going to go up until I hit the grid line that will form a 90-degree angle with my other point. So if I label it, this time I went up 2 and I went to the right 4. So back to our slope formula. Rise over run. The rise went up 2 and the run went over 4. And that would simplify down to 1/2. In general, the bigger your number is, the steeper it is, or the bigger the absolute value is, the steeper it is. So this line has a slope of 1/2. Okay, here's our next one. This time I can use the origin right here, the point 0, 0, and I can use this point right here. So now when I draw my slope triangle, I'm going to go up and over. So I went up 4 and right 2. So when I do rise over run, I went up 4, right 2, and that would simplify down to a slope of 2. So again, if you compare it to the last one that we just did with the slope of 1/2, a slope of 2 is going to be a lot steeper. One quick thing I want to point out, you could use any 2 points you want as long as they cross on the grid behind it. So I could have used this point and this point if I wanted. And if I draw my slope triangle here to here, this time I had a rise of 12 and a run of 6. So if I do 12 divided by 6, that will still simplify down to 2. So as long as you pick any 2 points where the grid lines cross behind it, those would count, and when you simplify it, you'll always end up with the same slope. Okay, next we'll use maybe this point and this point. So I'll still look at my vertical compared to my horizontal. Now this time the vertical distance went down 2, so I would write -2, and then it went to the right 4 spots. So now when I calculate my slope, I have a rise of -2 divided by a run of 4. So now when I simplify this one, I end up with a slope of -1/2, which does make sense because if you think about the car, it would be going down. So that's a slope of -1/2. Okay, next, this one is even steeper. So I'll use this point and this point. So again, I could pick any ones that I wanted as long as they cross the grid line behind it. So we'll draw our slope triangle. This one went down 20 and it went right 4. So when I do rise over run, I get -20 divided by 4. So that would give me a final slope of -5. Okay, this one is a positive slope since I'm going up. So if I use this point and this point, I'm going to go up 3, right 2. So that's going to give me a slope of positive 3/2. Now this one doesn't come out to a whole number when you divide. Now that we're calculating slope, it is okay, and in fact it's even preferred to leave your slopes in improper fraction form. That will help a little bit. It'll be a little bit better than doing 1.5 because we can easily see that it went up 3, right 2. Okay, this time we have some numbers to go along with our line. And instead of counting by ones, we're counting by different numbers. I went ahead and added in some tick marks just to help make sure that we're lining everything up. The x-axis is counting by 5s if you count every single line. And on the y-axis, we're counting up by 100 for every 3 lines. So here is a point where it crosses, and here's a point where it crosses. So we'll go ahead and draw in the slope triangle. Now this time we really need to pay attention to the scale. We actually went from 100 up to 400. So this distance, the vertical distance right here, would be a rise of 300. And then along the horizontal distance, we started at 0 and we went all the way up to 100. So that would be a run of 100. And again, they use different spacing on the x and y axis, so that's where we really need to pay attention to what those numbers are because it's not consistent within your graph. So we'll write our slope, rise over run, is going to equal positive 300 divided by 100, or that would be a slope of 3. Okay, same idea on this one. The x-axis across the bottom is just counting up by 1 each time, and the y-axis is counting up by 100 for every 2 spaces. Okay, now when we draw in our slope triangle, we're going from this point up and then over to this point right here. So we went from 600 to 800, which is an increase of 200. And then for the horizontal distance, we went from 0 to 20. So that would be a distance of just 20. So when we set up our slope, we will get 200 divided by 20, which would be a slope of 10. All right, and finally we're going to look at just a couple more pictorial examples where we've got people doing some things and we're actually trying to find slope of something. So for this one, what is the slope of the hill that the bike rider is riding up? He's going up as we go across left to right, so this is going to be a positive number. And he went up 10 for every 40 inches. So when we simplify it, we would have a slope of 1/4. Next, we have a skier, and he is going down 50 feet because this is a negative slope as he's going across left to right. So he's going down 50 or negative 50 and to the right 100. And so that would simplify down to negative 1/2. And finally, we have the roof of a doghouse. We'll look at rise over run. It's going up 1.5 feet, and it's going right 1. So our final slope would be 1 5/10. If you were writing it as a fraction, you could write 3/2. If it comes out to an exact decimal, that's fine. You can leave it like that. But just know that 3/2 would also be an acceptable way to write this one. Okay, quick summary of your slope. It's always going to be represented as the vertical change divided by the horizontal change, or rise over run. And there are 4 types of slope. There's a positive, a negative, a zero, and an undefined. All right, good luck calculating slope.